Hello everyone. Today we are going to discuss about logistic regression and my name is Shrihita Reddy Mutyala. So, what is logistic regression? Logistic regression is nothing but a statistical tool which is used for predicting the outcomes of binary values. Like if the answer possibilities are yes or no, pass or fail, in this situation logistic regression is used. Unlike linear regression, this regression is designed for predicting the probabilities. In simple language to tell, it's like answering a question with either thumbs up or thumbs down. It's just simple and direct answer. So this method is particularly useful when we want to figure out the likelihood of something happening or not happening. So throughout this presentation, we will discuss more about what is logistic regression. Coming to the diving deep into the logistic regression, what is it? It is a specialized version of the linear regression, but this is tailored for situations where we are dealing with categories, especially when there are only two outcomes. In simple terms, we can say that it is helpful whether to say if you're going to pass or fail in an examination, or if a customer is willing to buy a specific product or not in this case. So, the main idea is to estimate the probability of an event happening. It's all about predicting the chance of success or failure. So, logistic regression is versatile and widely used in various fields because of its ability to handle these yes or no predictions. Coming to why logistic regression, we have few things which has made logistic regression the better one. The first thing is applicability. When it comes to the applicability, logistic regression is our go-to tool when we are dealing with the outcomes, just like in two things such as success or failure or win or lose. And it also is best in avoiding the overshooting. Unlike some other methods, logistic regression keeps our predictions neatly between 0 and 1. Like it fits perfectly for the probability predictions. And it also has a probability estimation. Like it's good in telling us the probability of something happening. Instead of just telling yes or no, it also gives us a probability score. So these are some of the conditions by which we can say logistic regression is a better one. Coming to the comparison between logistic regression and other models, logistic regression is a superhero when the outcomes are binary. It's like the best one to deal these situations. The linear regression is not that suitable because it gives us some weird predictions which are outside of the range 0 to 1, which doesn't make any sense for probabilities. Whereas a logistic regression, it uses a sigmoid function and it maps our predictions to a smooth curve, keeping the things in a perfect for probabilities. As you can see in the figure, the linear regression value is exceeding the range of 0 to 1, whereas a logistic regression is exactly lying in between 0 to 1 range. Coming to the components involved in the logistic regression, we have three components. They are dependent variable, independent variable, and logistic function. So the dependent variable, it's nothing but we're looking for an outcome. Suppose if we consider a flipping of a coin, it could be like heads or tails. So this is the dependent variable, that is the outcome y. And the independent variable are the factors influencing our coin flip. If we consider an example such as a person passing in an examination, we can tell it by seeing the number of hours the person is studying. So here the number of hours the person is studying will be the independent variable, and the person pass or fail is the dependent variable. And coming to the logistic function, this is a smart logistic function. It's like the engine that turns our study hours, which we took in the pass fail example, into a probability score, and it keeps this thing smooth and orderly, and it makes everything and gives us a perfect prediction. You can see it here in detail. Like if this is a logistic regression equation where the p of I equal to 1 is the probability of the outcome being 1, where the e is the mathematical constant, and the b naught, b1, b2, so on are the coefficients representing the impact of each predictor, whereas the x1, x2, so on are the independent variables. So here the logistic function turns the linear combinations of these predictions into a probability between 0 and 1. It may look a little bit complex, but it can be detailedly explained in the sample scenario. Here I have considered a scenario where we want to predict if there is going to rainfall or not today. For that, I have collected the data about the temperature, humidity, and wind. And here I am training my logistic regression model using the formula, and I'm linking them to the probability of the rainfall. So, based on the values we had, now for a new day, if I plug in all these values of the temperature, humidity, and wind, it will predict me the probability of rainfall. So, what I can interpret is if the predictability, if I say it's like more than 0.5, then there will be an option to be a rainfall. And if it's less than 0.5, then I can say there will be no rainfall. And the regularization methods are L1 regularization and L2 regularization that can be used for the logistic regression. So these are used to prevent the overfitting in the model and to improve the generalization of the model. These are the two common types of regularization methods that can be used. Coming to the L1 regularization, it is called lasso regularization. So this lasso regularization, it adds you a penalty term to the logistic regression function, and it only will keep the most important features by keeping the spare coefficients, so that we can get a better model using the important features, and it will predict the more interpretability, and it will give you the regularization in a better way and reduces the irrelevant features in it. Coming to the L2 regularization, in this also add a penalty term to the logistic regression, but here it penalizes the large coefficients by adding the sum of squared values to the coefficient. Here, this L2 regularization will encourage the model to have a small non-zero coefficients for all the features. Like it will avoid the extreme values. So by this, a more stable model can be built where there are many correlated features. When you're dealing with a data set which has a high multicollinearity, then L2 regularization is the best option. So coming to the example I have taken, here I have considered a data set which shows the data about a person getting a heart attack based on the factors such as the person's age, education, is a person the current smoker, how many cigars does the person smoke per day, their blood pressure levels, their diabetes, their SYSBP, their heart rate, glucose, and did they get heart attack or not. So I have taken this data and trained my model based on that. In this, firstly, the dataset had few null values. So I have removed all the null values. And then I have drawn a correlation map for this. Uh, Then I have done the logistic regression, and here I have used the test and split, and then I have trained my model, and at finally I got an accuracy of 0.83 by using the logistic regression to predict the heart attack rate for a person. Next, I have used the L1 regularization to predict the value, and using the L1 regularization, I got an accuracy of 0.84. Then I've also used L2 regularization, and with L2 regularization, I have got an accuracy of 0.83. So, considering all the factors like the accuracy, F1 score, the precision, and recall, I have come to an analysis that, in terms of the accuracy, F1 score, and all, L1 regularization model performs the best compared to the regular logistic regression and the L2 regularization. So, mostly, which model to be chosen depends on the specific goals and requirements of our project. And based on this, for this model, L1 regularization model might be preferred to be used based on the accuracy and the highest F1 score it has. Thank you.